Hi everyone, I'm Loh Shu Yi, and this is the coding for our project. So we have created a cleaner robot. So at first we include all the libraries that we will use later. So the wire.h, f-motor.h, liquid crystal SPSC.h, the wire.h and liquid crystal SPSC.h are for the LCDs and the SPSC module. And the AF motor.h is to control the DC motors. Then we define the echo pin and the trigger pin for the ultrasonic sensor. The echo pin is connected to A0 and the trigger pin is connected to A1. Then we declare the variable, duration and distance. Then move to the next one, the push button. So the push button is connected to A2. And then we declare the DC motors. So we have 4 motors here, motor 1, motor 2, motor 3, and 4. And the command here is to show the position of the motor. Then next one, the LCD. We declare the LCD, and the LCD is at the address hexa 27. And the LCD type is a 16x2. So we go to the white setup. So we declare, we set up all the components here. At first, we set up the initialized LCD, then turn on the LCD backlight so that we can see the display message. Then we set cursor and print stop. Then we set the speed of the motor 100, and the motor1.run here release.run we release here is to stop the DC motor. Then we use the pin mode code to set the trigger pin, echo pin, and button to input and output. Then move to the next one. This debounce function is to debounce the push button so that we don't need to hold the push button for it to turn on. We just need to press and it will start to work. Then we created a function, scan. This scan function is to scan the distance. So here we set the trigger pin to high first, let it trigger the sound, and then after a few seconds, then it will set to low. And the echo, the sound and the duration will be received by the echo pin. So we set the echo pin to high and it will start to receive. Then we can calculate the distance here by using this formula. Then we move to another function, move stop. So this function is to stop the robot. So the LCD will display the stop here. Then the motor.run release is to stop the DC motors. So the 4 motors will stop. Then move to the next one, move forward. So the move forward here is to let the motor to move forward. So LCD display, move forward. Then the motor, the code here will be motor.run forward. So the motor, DC motor will start to move forward and it's rotating in the clockwise direction. So it goes to the move backward. So it's in the opposite direction, means that it's moving backward and in the counterclockwise direction. And then go to turn left. So for the turn left, the left side of the DC motors will moving backward and the right side of the DC motors will be moving forward. So for this, so the robot will turn to the left, and then we go to turn right. So for the turn right is the same, but the direction of the left side and the right side of the DC motors will be in the opposite direction. So left side will be moving forward and right side will be moving backward. Then we go to our main part, this while loop. So our main program is running here. So at first we will scan the distance, and then we'll call in the debounce function so that the push button can be used. So at first, the push button is not pressed, so the count will equal to 0. So everything will stop. We'll move stop here. So if the button is pressed one time, so the count will equals to 1. Then the LCD will show start reading. The robot will start to move. So at first we scan the distance. So if the distance is greater than 20 cm, the robot will move forward. If it's not, then it will stop and then turn left and turn right to scan the distance and then determine which side to move to turn. So we can see here, it will stop and turn right first, turn right and scan. So if the distance is greater than 20 cm, it will move forward, means that it will turn right. If it's not, then it will turn left to the left side. It will turn 2 times here, since the robot already turned to the right side, so it will turn left side 2 times, so it will turn to the left. So here, when it's turned to the left, it will start to scan the distance. So it's greater, it will move forward. If it's not, we will let it turn right side and back to the original direction. Then it will starting to move backward so that it can move away from the obstacle. Then after moving backward, so we will turn right again, turn right and turn left to scan the distance and determine which side to turn. So here is the same from the above coding. Scan, and if the distance is greater than 20, it will move forward. If it's not, it will turn again to scan the distance. So after all this, we will repeat this process 2 times. So after all the scanning process, if the distance is still less than 20, so the robot will stop moving, and then LCD will show I'm trapped and please restart here. And the for loop here is for the LCD to blink the message, and then we will make the count equals to 0. So the function will not loop back to the front and then start to loop non-stop. We'll make it to 0. So if the robot is moving smoothly, so if you want to turn off the robot, you will just need to press one more time. Since the moving part is count equals to 1, so if you want to stop, you press one more time and the count will equals to 2. Then the motor will stop. The DC motors, 4 DC motors will stop. Then LCD will print stop, and then the count will be back to 0. So let's compound and see whether there's any error. So there's no error here. Then we can move to the next part, the produce simulation and the harvest simulation.
Hello guys, I'm Kai Wen and I'm going to present the design of produce. So, Arduino Uno board is placed at the center, and LCD is placed here and is connected to BCF8574 IC, which is I2C expander, and is connected to a Arduino board with only 2 pins. So this method is called I2C LCD, and the advantage of this is Arduino can control the LCD with only just 2 analog pins, which is A4 and A5. Next is ultrasonic sensor. The trigger pin is connected to A1 and the echo pin is connected to A0 at the Arduino board. The sync pin is connected to the potential meter to manually control the value of the ultrasonic sensor when the simulation is running, and the potential meter is connected to power source and also ground. Next is the motor drive shell. The motor drive shell contains of three main components, which is L293D motor drive IC and 74CH595 shift register. The Arduino pin 4, 8, and 12 is connected to a shift register to control the direction of the 4 DC motor. The output of a shift register is connected to the input of the L293D IC, and the motor speed is controlled by the Arduino board by using pin 11, 3, 6, and 5 connected to the L293D IC, which on the enable pin to control the motor speed. Push button is connected to L2 to act as the on-off control of the DC motor. So, before we start our simulation, make sure that the ultrasonic hex file battery is included in the ultrasonic sensor, and the program coding is inserted in the Arduino board. So let's start our simulation. The LCD shows stop at start, and the DC motor is not turning. So when we press the push button, it will start turning and the motor start to move forward. But however, when the ultra sensor scan the obstacle in here, in front of it, it will stop and it will turn right, and then stop again when it scans. If there is no obstacle, it will move forward again and continue to spinning. So, what if the robot is facing obstacle all over the way? You will see that it will turn right and stop to scan whether it's obstacle, and yes, it will turn 180 degrees again to the other side and stop and scan, and there is this obstacle, and it will turn right back where it's facing front, and then it will move backward and then turn to the right. Then it will stop and scan again, but there is still obstacle, so it turn left 180 degrees again. Later will stop and scan, but there's still obstacle. So the robot thinks that it is trapped and is asking for help. And it will show the movement stop. So when I move the robot to a new place where there is no obstacle, manually change the sensor, there's no obstacle blocking him, and then we will press the push button again to restart the robot. It will start spinning. So that's it. If it's facing obstacle, then it will stop and it will turn to another direction, and then it will, when it finishes turning, it will stop and it will stand again. And if there is, it will turn the other side. So as long as after it stop and scan, there is no obstacle in front of it. Okay, scan, there is no obstacle, so he will continue to move forward. And after cleaning, we want to stop the robot. What we do is we just press the push button again and it will stop. Okay, that's all for me. Thank you.
Good morning, my name is Xian, and today I will do the hardware presentation of this smart cleaner robot. The component we are using is the Arduino Uno, and the motor driver shield is to control the direction and speed of the motors, and the LCD is to display the instruction. Ultrasonic sensor, this is to measure the distance. And we have the button to control start and stop of the motor. And we have the battery, 18650 battery as our external power. These are the 4 wheels, and the wheels is attached to the DC motor. 2 brush here is for the cleaning purpose. And this is the whole picture of our prototype. I start to test, I will insert the battery first. And the cable will connect to a power bank. And we are ready to go now. Initially, the LCD will show stop. Then when we press the button, the LCD will show move forward. It will turn left or right to see whether it has obstacle, and it will adjust its position. The LCD will show every movement of the robot, such as forward, left, right, stop, and if it is trapped, it will show on the LCD too. I'm trapped, please restart. You need to restart to let it move again. Even if it gets under the chair, it still managed to let itself to come out because it has the sensor. We can also use it to clean under our bed. The position is very difficult for us to reach, but it is very easy for it to reach. Push the button to stop. After cleaning, we can see that it can help us to remove the dirt on the floor. It is a very useful robot to use for home cleaning. And that's all from us. Thank you for watching.